Here we have a confidence interval question for two populations, sigma unknown. Okay, we've got a random sample of two call centers, and we've got the results in the table. The managers state that the populations of interest are normally distributed with equal variances. Okay, so we can use a student's T for this, develop a 90% confidence interval estimate for the difference between the two population means. Okay. Alright, so we're going to look at this here. The point estimate, okay, simple enough, x bar 1 minus x bar 2. Okay, and so that is going to be our sample mean. So we have 195 minus 216 equals a negative 21. So there's our point estimate. The pooled standard deviation, okay, we'll come back to that in a minute here, part B. We can construct, so far, we can construct a little bit of this here. We've got negative 21 plus or minus, and then if you look at part C, we're given the critical value, 1.651. Okay? And then we just have to multiply this by the pooled standard deviation as well as the rest of this. Now this innocent looking S sub p is actually all of this. Okay, so we have to calculate that now to come up with our pooled standard deviation, and then we will multiply by this portion here, 1 over n1 plus 1 over n2, and come up with our confidence interval estimate. And so while this is rather intimidating looking, there's just 4 pieces of information we need. We need n1, n2, and we need S1 and S2. Okay? Alright, and again, on this one, like in our working with proportions, don't forget to take the square root of all this at the end after all of these calculations. Alright, so we would have what we will do then. So our S sub p is going to be n1 is 120, so 120 minus 1, so 119 times 35.1 squared plus 134 here now times 37.8 squared over 120 plus 135 minus 2. And remember, that's also the degrees of freedom calculation there. Okay, when you calculate all of that, you end up with 36.55, and then you multiply that times the square root of 1 over 120 plus 1 over 135. Okay, and you multiply that all by this 1.651 so that you end up with then negative 21 plus or minus plus or minus 7.5709. Okay, so then what you end up with is you get the negative 21 in the center, you get negative 28.5709 here, and then you get a negative 13.4291 on this side, and this is the number of seconds per call. Alright, so based on the confidence interval, there is or is not a difference between the average lengths of the call at the two centers. Okay, so in this case we would say that there is a difference, right? So both numbers are negative. If one of the numbers were positive and one negative, you'd say, well, sometimes one call center can be shorter or longer, and vice versa in terms of their call length. But because 0 is not part of our confidence interval here, this does not cross 0 anywhere, we can say that there is a difference here. If there were no difference between the two call centers, the confidence interval would contain 0, right? If there was no difference, it would contain 0. That is, sometimes it's positive, sometimes it's negative, the difference between the two, and the confidence interval would reflect that.